This video is to give you an introduction to the Hayden McNeil Lab Simulations. This particular lab is called Introduction to Lab Simulations, and it will serve the purpose of allowing you to discover what's in the lab and how to use the equipment in the simulated lab. So what you'll see first is, of course, the title and then some background. I always recommend reading the background because the background will always have useful information, especially for this first lab when you haven't really used this before. Watching this video will help, but also reading through this background will also help. So go through that and it will give you some background as to how to use some of the equipment that you'll see in the lab. Then if you go to the next page, there's a little thing down here to go to the next page. And it will open up the experiments page. So it says here, and it says here in bold, you may need to move or resize the window in order to have both the procedure and the simulation at the same time. So this is the actual lab. That's what you'll click on and it will open the lab. Now it is supposed to open in a new page, but it doesn't for me. It opens in a new tab. So I wanted to show you how best to handle that. The procedures are down below this link, and those are what you'll need to see while you're actually doing the lab as well. So this is the best approach, I think. Click on the actual lab. You can see it opens here in a new tab. And what I would do is I would drag this tab off and have it as a new window. So as you can see now, it's a separate window. What I would do is I would grab the side here of the window and shrink it to about shrink it to about half for now. And we'll take the other window, we'll do exactly the same thing with that. Alright, so now that's how you should be seeing it and how you should be viewing it. As you can see, I'm just moving that over a little bit so it takes up more real estate. So I'll start the lab here, and it asks you to put on your personal equipment first, then you can enter the lab. Alright, so now you're in the lab. And you'll see it says here materials, containers, instruments. Now that's just because I've made this screen so small that these aren't coming up as the real pictures. So what I can do is, what I prefer to do is I'll shrink the procedure page a bit. As you can see, it'll move all the text over. Come back to that in a second. I'll move this over here like this, and now as you can see these all appear as pictures, which makes it a little bit easier, although you can do it the other way as well. So there you go, there's all your materials. Now if you click on the actual window, make that live, what you'll be able to do is mouse over these things. It will tell you exactly what's in there. So you've got water here, you've got copper, magnesium, zinc, and then if you need to see more of the things that are on the shelf, just click on the arrow and you can see that it will move things over, and you can mouse over and see what those things are. The same with containers, and the same with instruments here as well. Now what it says in the background is that everything revolves around containers. So all these instruments here are going to have, like these pressure gauges and these thermometers, for example, will be placed into containers, not directly into materials. So you'll see that as you go. But everything will be in the procedure that you'll need to do. So I'll do a couple of things here just to sort of get you oriented as to what's going on. So it tells you about these shelves, and then it says here to click and drag the 150 ml Erlenmeyer flask. So if you don't know what an Erlenmeyer flask is, just mouse over it until you find it. There we go, that's a 250 ml Erlenmeyer flask. You need 150, that's going to be the smaller one. So we'll take that, we'll put it on the bench. So what I did there was just drag it onto the bench with my mouse. Now it says up here, locate the 6 molar hydrochloric acid. Now when this 6M here, a lot of you might never have seen that kind of measurement before, but it's a concentration measurement, and you really don't have to know what it is, but you just have to make sure you get the correct material. Getting the correct material in the lab can mean the difference between a successful experiment or an unsuccessful one. It could also mean a dangerous experiment or a safe one, especially if you pick up something that's, say, too concentrated for what you want. You don't want to have any explosions or anything occur. Not that anything would here in the simulated lab, but in a real lab there would be that possible danger. So what I'll do is I'll go back over here and I'll look for 6 molar HCl or 6M HCl. It'll be labelled as such. So it's not any of these things here. We've got sodium bicarbonate, sodium carbonate, sodium hydroxide, 1.0 molar hydrochloric acid or HCl, and this one here is your 6 molar hydrochloric acid. So take that one and drag it down, and if you put it on the actual Erlenmeyer flask, it'll ask you to enter an amount. Now here in the procedure, let's go to procedure and see exactly how much we need. It says 50 mils. Alright, so you drag that onto the flask and then you type in 50 and it will add 50 mils of 6 molar HCl, and you can even see there the flask with the stuff in it. So we can actually zoom in on this as well, just if you want a closer view, and you can move over as well, especially if your zooming doesn't quite work out so well. You can see, you can zoom in, you can see the stuff in it. Now once it greys out like this, that's as far as it can go, but then you can go back like that. At this point we've added the 50 ml of hydrochloric acid to the Erlenmeyer flask. It talks about what happens when we have two containers interact. Instruments also will snap into place as well when they're placed on the Erlenmeyer flask. So that's the next thing we're doing here, is we're grabbing an instrument, and I'm going to move this over briefly so that I can find my thermometer. Then I'll shrink it again once I've got the thermometer in there. Alright, so there's a thermometer there, and I know that because I'm mousing over it, it says thermometer. So I can go ahead and grab that and stick it into the Erlenmeyer flask. You can see I can change the mode of this as well. I click on that, change it to Fahrenheit and Kelvin, but let's leave it on degrees Celsius for now. And I'm just going to, well, I'll leave that open, then I will shrink it from the other side here, it might be better, and bring it back to the way I had it. Alright, there we go. So I can still see the procedure here. So this brings me to the other thing I want to show you here, which is this lab report sheet, or this data sheet, that I have put in the same folder as this video so that you can download it and you can put your results on here rather than having to write them down separately. So as an example here, I've put this piece of data. It says an amount of water added to flask, and then it's a number followed by a unit. So I really want you to be mindful here of using numbers and units when you're recording data. So how do you know what unit to use? Well, common units we'll see will be milliliters for volume, grams for mass, degrees Celsius for temperature, and say atmospheres for pressure. And generally speaking, the unit will be on the instrument if you're measuring it with an instrument, and otherwise it'll be either a volume, which will be in a flask, so it'll be milliliters, or it'll be a mass that you've measured, so it'll be grams. So generally figuring out what unit using is not really going to be that much of a challenge, but you are expected to put down a number and a unit here. So for here, you can either print this out, or you can just go ahead and write on it like I'm doing here. This would be, it's said to add 50.0 mils, I believe. So whatever it happens to be. No, it says 50 mils, so whatever whatever it has there, just go ahead and write that in. 50 and 50.0 you'll see are going to be different numbers, and we'll talk about that later when we get to significant figures, but just whatever it puts in there, that's what you'll put. And now that we've got an initial temperature of the HCl, because we're asked to record that as well, if you look at the procedure here, so it says drag the thermometer into the oil flask, let it go, and record the temperature of the HCl in the flask. So we're going to use that later to compare it, to see how much the temperature might have changed once we do something else with it. So as you can see here, and we can get rid of that as well. I've just sort of kept it in a window behind, but if I click on this and then I click on this, then both of those will be at the front, and then the Word document can be at the back. And then if it's not Word, you're not using Word or something else, then whatever it is will just appear in a different window, which will be behind these two windows. And you can't see it here, but I've got a Word icon down the bottom of my screen, and you'd have something similar on yours, whether it's a Mac or a PC, where you can just click on that and it will bring it back up. Alright, so now it's back behind everything, so I've clicked on these two windows here. To actually give you enough of an idea about what you'll be doing with this, and then how also to put your data in on the sheet. So this one, I will put the measurement of the temperature in here, 21.5, and I'll just write degrees C. If you want to, you can use a degree symbol, but otherwise it's probably just easier just to write degrees C, and then that's all you would do for that. And then you would move on and you would continue with the rest of the lab, filling in the data. I am expecting you to hand in this lab sheet, this lab data sheet, as well as do whatever assignment is going to be part of the lab report for this lab.